We have created very short videos to summarize a book entitled Learning the Brainstem. The voice you hear is AI generated. LTB 11 continues the discussion that we started in LTB 10. Again, we are at the level of the facial colliculi and pons. If we look lateral to the right facial colliculus, we visualize a triangular area which does not stain as darkly as the middle cerebellar peduncle, for example. Within the area is part of a sensory nuclear complex, part of the vestibular column. And the area is termed the vestibular triangle. The apex of the triangle points at the descending spinal tract and nucleus of CN5 or trigeminal nerve. There's a tendency to think of vestibular nuclei as being located just in the medulla, lower than where we are now. There are vestibular and cochlear nuclei in the medulla, but a column created by vestibular nuclei, no less than 4 nuclei, extends to our current level of pons. Since a fundamental task of the vestibular system is to help control eye movements relative to the head's position in space, it makes some sense that vestibular nuclei would be anatomically close to locales involved in saccades of the eyes. In changes of our visual gaze, our eyes move conjugately under normal conditions. Now, if we draw a yellow vertical line between the facial colliculi from floor of fourth ventricle to the ventral surface of the pons, what structures, with an emphasis on tracts, might we be able to identify on either side of the line? Within the translucent whiteness that extends from the vestibular triangle laterally to the midline, from medial to lateral, we can identify a bit of the medial longitudinal fasciculus, or MLF. We know from earlier videos in this series that the tectospinal tract sits very close to the MLF. We indicate it with another red arrow. It is a descending tract. If we move our translucent white rectangle more ventrally, the rectangle now extends from the descending spinal tract and nucleus of CN5 laterally to the midline, we encounter, as marked by the light blue arrow, a paramedian area of dark stain ventral to tectospinal tract, an area termed the paramedian pontine reticular formation, or PPRF. The PPRF is medial to the central tegmental tract, which we indicate with an orange arrow. If we move the translucent rectangle even further ventrally, we encounter the medial lemniscus, indicated by the yellow arrow. The medial lemniscus is an ascending tract. As it happens in this particular image, at the lateral aspect of the medial lemniscus, the rubrospinal tract is rather distinct, as indicated by the green arrow. The rubrospinal tract is a descending tract. In this image, the rubrospinal tract looks like a ventral extension of the central tegmental tract, the latter indicated by the green arrow at an angle. But they are discrete tracts. Both the rubrospinal and central tegmental tracts remind us that there is connection between red nucleus in midbrain and lower brainstem and spinal locales. If we move the translucent rectangle almost to the ventral surface of the right hemipons, we see fibers of the descending corticospinal tract collecting into the right pyramid, indicated by the white arrow. Areas of grey surrounding the pyramid are pontine nuclei. In this video, with the exception of the nuclear complex in the vestibular triangle lateral to the facial colliculus, we have concentrated on ascending and descending tracts. Let's review them now. As indicated by the red arrows, we have MLF and the tectospinal tract. As indicated by the blue arrow, we have PPRF. As indicated by the orange arrow, we have central tegmental tract. As indicated by the yellow arrow, we have medial lemniscus. As indicated by the green arrow, we have rubrospinal tract. As indicated by the white arrow, we have the collecting fibers of the pyramid. We have concentrated on tracts in LTB 11. Now I want to discuss the relationship between PPRF, MLF, and one nucleus. In this image, I have enlarged the pontine tegmentum, and I want to concentrate first on the contents of the yellow circle. There's a bit of abducens, or CN6 nucleus. There's a bit of MLF. There are infranuclear fibers of CN6. They emerge from the medial side of the nucleus. The abducens nerve will exit at the ventral surface of the low pons. If we move the yellow circle ventrally, we are in the area of the PPRF. CN6 nucleus is not the same as the PPRF. The nucleus contains not only motor neurons related to the control of the lateral rectus muscle of the right eye, but also interneurons whose fibers cross the midline at this level to ascend in the contralateral MLF. In generating a saccade of the eyes towards right space, interneurons in right CN6 nucleus receive excitatory bursts from the right PPRF just as CN6 motor neurons do. CN6 nucleus also receives afferents to it from the vestibular nuclear complex. A unilateral lesion of CN6 nucleus, with destruction of both its motor and interneurons, produces an ipsilateral gaze palsy in which both eyes can't move to the right. In unilateral lesions of CN6 nucleus, there is also what has been called an obligate ipsilateral facial palsy due to involvement of the facial nerve fascicle, which is dorsal to the nucleus, as indicated by the grey arrow. A lesion of right PPRF also results in a palsy in which both eyes cannot look to the right, but there is no associated right facial palsy. We are in a position now to review the MLF from pons to midbrain, and PPRF will be a part of the story. That review is our task in LTB 12. For now, as always, thanks for watching.